What's the proper way to draw an angle in the coordinate plane? Well, first of all, we're going to have to use the positive side of the x-axis for one of the rays. So use the positive, let's spell it correctly, positive x-axis for one, I would say half of the angle, but I want to be careful that I don't say that in a context of like, oh, half the measurement. But for one of the rays, one of the segments of an angle. One ray, there we go. Just one guy named Ray. All right, let's start by drawing a 60-degree angle. If I wanted a 60-degree angle, and I've been given a coordinate plane here, then I'm gonna start, well, with the positive side of the x-axis, and then I'm going to open this angle up, well, 60 degrees. So about like that. Actually, got a little protractor on here that you can barely see. It's right there. It's exactly that. That is 60 degrees. It's right down there. And there is your angle. So there we go. Now, I use the word ray, so it can go forever this way and go forever this way. Sometimes we'll put a little dot to show that it ends. We're not going to get too picky concerning, like, does it go on forever or does it end at one point? We're just going to be talking about how open the angle is and the proper placement of that. And I want to point out that this, right here, is 60 degrees. It starts here and it goes up from there. All right, so keeping that in mind, I think it's very obvious but important to note that we are going to be using 0 degrees on this axis. We're going to be using 90 degrees on this axis. This is going to swing all the way around to 180 on this axis. And then 0, 90, 180, what comes after that? Well, 270. And then if we go all the way back around to 360, we're back where we started. Okay, good to know. It's going to help us as we move forward. So I want to draw a 190-degree angle. Well, I always have to start here. Always have to start here. And I'm going to swing this thing around 180 degrees, but I need to go 10 more degrees. So I'm going to swing it around a little bit further. So here's what happens. I've got this, and it's going to go. And I'm going to estimate this one. I'm not going to draw it as exactly as the last one. Ooh, that is off. Because that means that should be a 10-degree angle. And it's not exactly perfect. But this opens up 190 degrees, because there'd be 0, 90, 180, and then 10 more. So that's a little more than 10 just by eyeballing it, but that's roughly where 190 would go. Okay, let's do a 359-degree angle. I wonder what that looks like. Okay, well, we have a 0-degree angle here, and we're going to swing this thing around. Notice that's almost 360. So a 360-degree angle would put us exactly back where we started. So we're going to end up 1 degree away. Now that is not 1 degree. Again, eyeballing it. It goes around like that, and that is a 359-degree angle. I'm drawing this little arrow to show which direction it's going, which will come in handy when we go to the next one and we have a negative angle. Now we're always going to use the positive side of the x-axis for one of the rays, and for the other ray, which we're going to call the terminal side of the angle. That's the way textbooks call it. The other ray is going to be the one that just kind of swings around wherever. So negative 60 degrees. So instead of going 60 this way, negative is going to send it this way. So if we're going to have a positive angle, we're going to go counterclockwise. Notice the direction of this. That's the opposite direction a clock runs. Negative angle is going to go clockwise, which might be a little intuitive, but that's the way it is. So here's a 60-degree angle right here. This one's going to be exact, not poorly estimated and eyeballed. Here's a 60-degree angle, and I am tempted to say, oh man, a 60-degree angle right there. Yeah, it is, and it is. But it's a negative 60 if you want to get technical, because we're dealing with something in the coordinate plane. So we're going to have to go in the appropriate direction based on the signs. There's a smudge on my paper and it won't go away. It makes me mad. All right, a negative 120-degree angle is a 120-degree angle in the wrong direction. So let's speed this up a little bit. So instead of having a 120-degree angle that swings that way, it's negative, so it's going to go, whoa, that way. And it is going to be exact. We'll do it exact this time. There's that. And there it is. Negative 120 degrees. Okay, negative 270. Now, let's go back to the very beginning. These numbers that I put on the axes, I could put these on all of them. I just chose not to because I don't want to clutter up the picture. But basically, if I have a 0 degree angle, it's here, 90, 180, 270. So if I'm asking for negative 270, then it's going to be in the opposite place than the 270 is. Notice this. Notice that a 60 degree angle and a negative 60 degree angle are reflected over the x-axis. So a 270 degree angle and a negative 270 degree angle are going to be the same. So if I go from 0 degrees to negative 90, negative 180, same place as 180, and negative 270, I end up here. Now, we're getting ahead of ourselves, or I'm getting ahead of myself as I say this, but, whoop, a little too far there. This negative 270 degrees is the same place as a 90 degree angle. So we're already making a few connections and we're saying, well, you know what? Maybe if I go in the wrong direction, I'll end up in the same place as something else. So I could say I have a 90 degree angle in the coordinate plane. You could also say I have a negative 270 degree angle, depending on the context. Okay, a 361 degree angle, well, it's going to start right here. Better. And it's going to swing all the way around to 360 degrees, and then it's going to go just a little bit more. Now that is more than a 1 degree angle, but I did my best. I'm sorry. So it started here and it swung, not just there, but it swung all the way around to there. That's 361 degrees. And notice that this one was positive, so we went counterclockwise. Okay, a 450 degree angle, clearly larger than 180 degrees. Sorry, larger than 360. Well, clearly larger than 180, but also larger than 360. So we have a 450 degree angle. So I know I'm going to go all the way around the circle. I know that. But how much further am I going to go than a 360 degree angle? So at this point, and I know the answer and you know the answer as well. It's 90. But if I just want a visual for it, here goes. I'm going to go all the way around, but how much further am I going to go beyond that? This is where you have to say, oh, I'm going to go that much further. So this is the process that happens in your head. It's kind of intuitive, but that's what happens. There we go. So it's a 90 degree angle, right? Which is the same as a 270 degree angle, which is the same as a 90 degree angle. So this, I'd love to stop it there, but it actually went all the way around to here, and this is a 450 degree angle. My font got a little different there. Now we have a negative 405 degree angle. So I know I'm going to go all the way around in the wrong direction. Well, the right direction because there's a negative, but in the direction that I'm not used to going because of the negative. So I'm going to go all the way around and then I'm going to go some more. But how much more am I going to go? So let's just pretend like it's positive for a second and we're going to subtract 360. It's going to be 45. But I'm going to go 45 degrees in the negative direction. Still not quite right. Man, I'm having a hard time eyeballing these things. So I'm going to go not positive. I'm going to go negative 360, and then I'm going to go 45 more. So that is a negative 405 degree angle. All right, I think it's important to make a couple connections here. I've said this before, but I want to say it again. Sometimes angles end up in the same place. And also, we're going to introduce some vocabulary that'll help us with that in a moment. It's going to be called coterminal, but it's basically angles that end up in the exact same place. And the standard position for an angle is basically going to be where we have a side that is on the positive end of the x-axis. I haven't said standard position of an angle, but that's what it really means. And I said the phrase that goes along with it right up here.